This is
our sensor. It's a depth camera.
Okay.
Or we call it snapshot scanner sometimes.
And that's how the robot can see.
If you don't trust it, I can put my cell phone in there.
Oh, okay.
Yeah.
Boom. Oh, the little teddy.
Yeah, here's your little teddy bear, my phone, my cup, all scanned, and the clamp.
Impressive. Can we try it with something bigger?
Yeah.
All right.
Yeah, it's very often when people use big rigs. We have an example here. Our welding engineers use this thing. You see, and we'll insert some part in here.
Okay.
Let me do that. It's heavy. There can be different kind of fixtures on real production because it's a very individual thing, and many of our clients use their own rigging or fixtures. And for us, it's not a problem. As I said, we don't use any model for the clamps or for fixtures, so it's fine. The interesting thing is that this rigging is basically bigger than the part. So the part is smaller than the fixture.
Cool. Excellent. Now our part goes in here, yeah?
Yeah. Okay. Right, yeah. I'm gonna fix. So we select this part. Here we have a model. I selected one weld. It's gonna be PB orientation, so now the positioner will rotate when we're welding it. Yeah, and again I do check reachability, add to cell, full scanning, and just run it.
And the 3D camera here, that hasn't seen this before?
No, never. So this is the first time the 3D camera is going to see this, this thing, the whole thing. So here you see that now the part is here. And the whole huge rigging is here.
That's beautiful.
And we can see it, and we won't collide into it.
And the system has told you that it's ready to go?
Yeah.
And if you want, you can weld?
Yeah. You can, if you don't like it, for example, for some reason you see that something is not recognized, you can always stop execution or rescan it if you want, or even change some parameters. But now everything is totally fine, so we can just confirm and see how it's going to weld the joint that we selected. Okay, ready to go. We can go again and see. So now it's touching. You know, there are 5 senses, right? Vision, touching, hearing, smelling, and what? And tasting.
Taste, yeah.
So our robots can do 2 of them. And again, it really precisely goes directly into the weld as it should be.
So I called it a 3D camera. Is that correct?
Yeah, it's different from ordinary camera because it also captures depth.
Right.
So we get 3D information.
Ordinary camera. Okay.
Yeah, this is the
3D
ordinary
camera.
This
Depth.
is 3D
Okay,
camera.
so this catches.
Yeah, it caches depth, and we can convert it to point clouds that you saw on the screen. And we use different cameras.
Yeah, this is very small.
This is very small, and it's relatively cheap, but it gives a bit less quality. But it's small and cheap, so we can install it on a robotic arm, and it does not influence the reachability. So you see the torch, and sometimes we need to get to some really tiny, really small spaces. And this camera let us do it.
Why would you need two cameras with one piece?
We don't need actually, so because we can move this camera, it's on a robotic arm, so we can move it anywhere and scan from all angles, and we can also rotate the positioner. And so this kind of cameras is good when you have a relatively small cell with positioner, and it's very flexible when you need to see the obstacles, the rigs, the clamps, and so on. Some of our clients don't use rigs or any kind of clamps, so they just have huge pieces. And in this case, we use that camera, the big one that is installed on the track.
If you want to scan something bigger, you need a guy like this?
This scanner has a much bigger field of view, and it's much more expensive, and the quality is much higher. So the accuracy of this scanner is split millimeter, I
really?
think. Yeah.
Where's the lens?
The lens is on this side, and the projector is on this side.
Cool.
And you can see that it's too big to be mounted on the robot arm itself, not like that one. So we mount it on the linear axis. You see this thing is attached to the track, and it moves together with the robot. It has a wide field of view, it has good quality, but the thing is that you can't see from different angles. But in this application, it's not needed. For many of our clients, they don't use any kind of clamps or rigging, and it's okay for them.
What kind of thing would you...
Do you mean what kind of parts?
Yeah.
Something like this. This is like a minimized version of real parts. Another thing is that we can combine. So on this cell you can see both of them, big guy and small guy. They work together, no problem. So it increases the visibility because this guy sees the part from this side. This guy sees more to the front. And and this is the way it works. So higher quality, higher price, wider field of view, lower quality, lower price, lower field of view, lower size. And we have another guy over there. It's the same as this one, but with a huge field of view. And it works with the yellow robot. And I can show you how it all works.
Cool.
Let's go.
So?
Yeah, so let's scan. So you see it now moves only along the track. And you can see the red blinking light. It's a laser projector working.
Right.
You can't see the projector of the small guy because it's infrared, but you can see it, the projector of the big guy, which is like just a regular red light. Yeah, that's it. You saw it can do it only in 3 shots. Now here's the result. Here it is.
Lots of green.
It's all green because everything is good. Only this part is red because it's far from the model and it's just kind of an obstacle. But on this cell, we don't enable, we actually disabled the detection of obstacles because we know that by design of the cell, we can't see the part from this side, only from that side. That's why we don't have points here, you see? We have points here.
Yeah.
But we don't have points here.
It's a shadow zone.
Yeah, this is a shadow zone. Here you can see that some parts of our object is in the shadow, so we don't have points here. But the quality of the scan is really high. As I said, we can change the opacity. And here you can see that the points are really flat, even though we scan it from a really big distance. So the scanner is over there, so it's like 2 meters here, and it's still really high quality. It's expensive and big. This is the reason for high quality. And with if we go back to that cell where we have the small guy. It's really nice that it's small, but the quality is lower. We can see some noise, but it's not a big deal for us still. Yeah, it's just a difference, and we can work with the different devices. So, and we can try to scan with that guy. It's also really interesting because it has huge field of view. So let's just do it.
And it's going to scan a little part similar to the...
Yeah, and the scanner is on the wall, so we use only positioner for rotation.
Right.
So the positioner, it bends, so the angle between the part and the scanner is optimal. And then it just rotates that the scanner can see this part from different sides. And this is the same part as we have on that cell, so we can compare the quality of the scans. The good thing is that we are really flexible with the scanners in our system. You see that one is mounted on the wall, this one is mounted on track, and that one is mounted on the robot arm. Okay, here we can see the result now. This is the part, the half boat as we call it. So, and you can also see that here we have some rigging, some fixtures. And if we change the opacity and change the size of points, you can see that the quality is really good. All the surfaces are surfaces, the points are green. Again, we can compare it with the data from another scanner. And here you see that more data is like fluctuating and so on. So yeah, that's the difference between the scanners.
Great, cool. So do you use machine learning and AI?
Yeah, AI, definitely yes, because AI is really trendy and really powerful, but we use it only in some particular places where it is really well suitable.
Such as?
I can't get you into the details that much because it's our intellectual property. But yeah, I think that we are combining it in a clever way with other mathematical methods and algorithms, which don't rely that much on data, because data collection and markup for AI is really difficult task.
Who writes the algorithms?
We, engineers. And we have, I should say that we have our own algorithms. So they are state-of-the-art. It's not that we used some algorithms from some open source library or something like that. Many of key algorithms in our system are developed by us.
So they're proprietary.
Proprietary, yeah.
So what's the difference in sensitivity between the human eye and what we have here?
Okay, first off, I would start with accuracy. So, as far as I know, human eye accuracy is about 1/3 of a millimeter. And with these scanners, we also have split millimeter accuracy for the point cloud, for the point cloud Z noise. But a very different thing is that human eye can recognize, because our brain can recognize well, and these are just sensors. And to help them to recognize, we need to develop some algorithms.
Yeah.
And you mentioned AI. AI is really good for recognition tasks. Human eye is a clever sensor, but it's because it's connected to our brain. And here, our sensors are connected to the brain of a budget system, which lives here or in the ABAGY box.
Great. Cool. Dima, thanks.
No problem.
Thanks for sticking to the end. We'll be posting regularly, so subscribe. Stick some comments if you like about what you saw today, and we'll be back with more robotic welding innovations.